The general operation as explained on this page should not be confused with the more specific operators on vector spaces. For a notion in elementary mathematics, see arithmetic operation. In its simplest meaning in mathematics and logic, an operation is an action or procedure which produces a new value from one or more input values, called operands. There are two common types of operations, unary and binary. Unary operations involve only one value, such as negation and trigonometric functions. Binary operations, on the other hand, take two values, and include addition, subtraction, multiplication, division, and exponentiation. Operations can involve mathematical objects other than numbers. The logical values true and false can be combined using logic operations, such as and, or, and not. Vectors can be added and subtracted. Rotations can be combined using the function composition operation, performing the first rotation and then the second. Operations on sets include the binary operations union and intersection and the unary operation of complementation. Operations on functions include composition and convolution. Operations may not be defined for every possible value. For example, in the real numbers one cannot divide by 0 or take square roots of negative numbers. The values for which an operation is defined form a set called its domain. The set which contains the values produced is called the codomain, but the set of actual values attained by the operation is its range. For example, in the real numbers, the squaring operation only produces non-negative numbers. The codomain is the set of real numbers but the range is the non-negative numbers. Operations can involve dissimilar objects. A vector can be multiplied by a scalar to form another vector. And the inner product operation on two vectors produces a scalar. An operation may or may not have certain properties, for example it may be associative, commutative, anti-commutative, idempotent, and so on. The values combined are called operands, arguments, or inputs, and the value produced is called the value, result, or output. Operations can have fewer or more than two inputs. An operation is like an operator, but the point of view is different. For instance, one often speaks of the operation of addition, or addition operation, when focusing on the operands and result, but one says addition operator, when focusing on the process, or from the more abstract viewpoint, the function plus r, s or s. General description: an operation I_ml is a function of the form I_ml of e or y, where v(x1a, a euro a, xk. The sets xk are called the domains of the operation, the set y is called the codomain of the operation, and the fixed non-negative integer k is called the type or arity of the operation. Thus a unary operation has arity 1, and a binary operation has arity 2. An operation of arity 0, called an Unary operation, is simply an element of the codomain y. An operation of arity k is called a kr operation. Thus a kr operation is a relation that is functional on its first k domains. The above describes what is usually called a finitary operation, referring to the finite number of arguments. There are obvious extensions where the arity is taken to be an infinite ordinal or cardinal, or even an arbitrary set indexing the arguments. Often, use of the term operation implies that the domain of the function is a power of the codomain, although this is by no means universal, as in the example of multiplying a vector by a scalar. See also, algebra, Unicode mathematical operators, special cases, unary operation, binary operation, related topics, notes, see for example Chapter 2, Definition 1.1 in, S. N. Burris and H. P. Sankapanava, A Course in Universal Algebra, Springer, 1981. 1.